we answer the questions actually same. So let's look at question number 11. This one. Question number 11. Question 11. Frictionless piston cylinder device contains 8 kg of superheated water vapor at 500 kilopascal and 300 degrees C. Steam is now cooled at constant pressure until 70% of it by mass condense. Determine the work done and heat transfer during this process. So last week we have learned the energy balance equation for closed system. Then we learned about boundary work or work done. Then we also look at the heat transfer. So now let's solve this question, question 11. As usual, have to write all the value given from the question as well as the clue. So we have to find some hints and clue the questions. As usual, step number 1, have to write down all the value given in the question. So the first one is a frictionless piston cylinder device contains 8 kilogram of superheated water vapor. So M is kilogram. Phase 1 is superheated vapor. Phase number 1 is superheated vapor. kilopascal is P1, pressure 1, initial pressure. 1 is 500. Kilopascal. So 1 is 300 degrees C. Steam is now cooled at constant pressure until 70% of it. So constant pressure means P2 now is state number 2 because steam is now cooled. Okay, steam is now cooled means that they have another state or state number 2 or say as final state 2 where the constant so equal to P1 until 70% of it by mass condense. What does it mean? 70% of it condensed. X, we can find X. So X equal to what? 0.7 or 0.2 or 0.3. So you have to look back at of quality. What does it mean? Quality. What is the meaning of quality? You can determine the meaning of the quality, then you know the value of X from the hint given in the question. 70% of it by mass condensed. So let's look at lecture note, chapter number 2. At note, chapter number 2. Note, share with you the lecture note. Find quality. Okay, this is quality. The ratio of the mass of vapor to the total mass of the mixture. X equal to mass of vapor, separated vapor over mass or over total mass. So from this statement, steam is now cooled constant pressure until 70% of it by mass is condensed. That means X here is equal to 0.3, not 0.7, but 0.3. So X is 0. If you can't determine the meaning of, can't define the meaning of quality, then got wrong. So for this question, because once quality is 7, then your final answer wrong. Okay, so what else? 70% of it by mass condensed. Then determining the work done and heat transfer during this process. So we have to determine W, okay. So this is step number 1. Step number 2, for PV or PV diagram. Okay. Diagram. So from the value given or property given in the question, P and T, both property, both pressure and temperature are given. So it's up to us, it's up to you, or TV diagram or PV diagram. So for me, I prefer to or T versus V diagram. Pressure. Then step number 3. Step number 3, transfer all the properties, all the value given our diagram. So P is 500 kilopascal. P here is P1, okay? P1 equal to 500 kilopascal. And 2, final pressure also equal to P1. 1 equal to P. And temperature is 300 degrees C, and or we plot the number of 300 degrees C, we have to find this saturation temperature. Find this value first, T set. So T set at the given pressure. So look at pressure table. The substance here is water, right? So substance is water. Superheated water vapor. So the substance is water. So now we have to look at table A4, 5 or 6. So pressure is given 500 kilopascal. So go for pressure table. Look at pressure table A5, and then go for 500 kilopascal. So at 500 kilopascal, the saturation temperature is 151. 151.8. Okay. So the given temperature T1 or initial temperature is 300 degrees C, and the phase is superheated vapor. So here is 300. Okay, of course 300 is larger than 151.83. So can determine the location, or we can plot state number 1. So here is state 1. Next, for state number 2, we have x equal to 3. That means state number 2, the phase is saturated liquid vapor mixture. Since we have x equal to 0.3, therefore the phase for state number 2 is somewhere here. This is state 2. Saturated liquid vapor mixture region. That is state number 2. And the process is look like this, from 1 to 2. Okay. I think that's all for step number 3. We transfer all the value given person into our diagram. You can also draw this one. Okay. Help us later on in order to determine the work done and the heat transfer. 1 and B2. Okay, next, step number 4. For step number 4, by using the equations that we have learned, determine the work done and heat transfer during this process. Process number 1 to number 2. First, work done, WB, okay, boundary work. Then last week, boundary work is equal to integral 1 to 2 A. Okay. Okay, next, P is constant, P1 equal to P2. That means the process is isobaric. Okay? Isobaric. The process here is isobaric. Constant pressure process. So the integration become as P 1 to 2 bracket volume 2 minus volume 1, or we can write as specific volume 2 small v2 minus small v1. Because we have learned before this, volume equal to n small v. So please remember this equation. Okay, M is given, which is 8 kilogram, P 500 kilopascal, V2 and V1 we need to find first. Okay, find both value V2 and V1 from the table. So the table that we need to refer to is pressure table, water table, pressure table, saturated water pressure table. Because pressure is given 500 kilopascal. So here F is 8 kilogram, 500 kilopascal. Is V at the given, sorry. V2 okay, V2 this one, this V have to use the equation, right? Equal to plus x okay. For V2, you need to use these equations. F at the given pressure plus X VFG at the given pressure. While for this V1, so you have to use table, have to look at table. Last week, for the case of superheated vapor, table A6, they have a lot of small column. So in the small column, for each small column, they have their own respective pressure. So find both value. Learn about it last week. So once you get the value, once you know this value, then you need to put, for this case, here, 1. Okay, this is how we solve the problem. The final answer for this case, for boundary work, should be minus 168 kilojoule. Okay, minus 1638 kilojoule. So last week also during lecture session, we have learned about the symbol positive and negative for work and heat. So for the case of work, if the value is negative, that's mean work done on the system. So W in. So in this case, you can change this minus into positive by to write or to mention work done on the system. Okay, so you can change this negative symbol into positive, but have to mention work done on the system because it is work in or W in. Next, for the case of Q, for the case of Q, you have to apply the equations of energy balance equation for closed system. So the energy balance equation is Q minus W out equal to delta Q. By using this equation, energy balance equation for closed system, we can determine Q, heat transfer. So this one, so Q net in equal to Q net in equal to del W net out plus delta So this W net out is actually W minus W out, or W out minus W in. One. W net out equal to W in minus W out, or W out minus W in. One. It's W out. Okay, not W in. W out, W in, bracket, plus okay. So next, for delta E system, delta U plus delta KE plus delta okay. Now let's look one by one. For the case of W net out, okay, is W out minus W in plus WB. So in this question, W out and W in are not given. W out and W in are not given. So we can cancel both W out and W in. Only WB is remaining. This WB is actually come from value. WB. Okay, minus 1638. Don't use the positive one. Use the actual one, which is minus 1638. Why? Because 1638, the positive one, we mentioned here work done on the system. So we cannot use that one. We need to use the actual one, which is minus 1638. This is WB. Okay. Next, for the delta E system, for the case of delta E system, delta U is the change of internal energy. So if they have a substance, any substance, they have their own internal energy. So we need to consider U. But for the KE, kinetic energy, doesn't we are not given any value of kinetic energy and potential energy. So we can cancel both KE and okay. So if you look at the questions, it didn't mention anything about kinetic energy and potential energy, because this is piston cylinder device. So this system is not moving. Piston cylinder device is not moving. So therefore, KE equal to 0. And then the potential energy of this system, the piston cylinder device itself, it is located on the ground, not on the top of any hill or mountain. So therefore, potential energy for this system also 0. So we can cancel both delta KE and delta PE. So what in the remaining property is only delta U minus 1. So bracket small 2 minus small 1. So to find U2, okay, 1. Both U2 and U1 you can find from here. 1. Second is U also C. Okay. So for U2 and 1, untuk U1 dan U2, you gunakan kaedah yang sama seperti mana kamu dapat V2 dan juga V1 tadi. Okay. So once you get the value of U1 and U2, then you can answer QNet in. In the value for Q minus 14 2.11 dojo. Still negative. Okay, the answer. The answer for W. Okay, ada soalan? Apa-apa soalan yang ingin ditanya? Saya ulang sekali lagi, untuk dapatkan internal energy 2 dan juga internal energy 1, use the same method as what you did for specific volume 2, V2 and specific volume 1. So we have to use the equations, then look at table A6 as well. But this U2. 1. Ada apa-apa soalan dan nak ditanya? Siapa yang tak faham?
Saya tak faham daripada QNet in dengan QNet out.
Net in dengan
WNet out.
tak faham macam mana tu? Apa yang kamu tak faham? Boleh jelaskan apa yang kamu tak faham? Okey. Senyap. Siapa yang bertanya tadi? Okey, tak apa. Saya buka satu lagi whiteboard. Okay, untuk dapatkan W, untuk dapatkan Q, okay, sekarang ni soalan yang kedua. Kita perlu dapatkan Q, heat transfer. Okay, so in order to find this value for Q, have to look back at the energy balance equation for closed system. Kita belajar. Why? Because in this equation, they have Q, right? Q net in. Kita nak cari yang Q ni. Net in, nilai bersih. So, the energy balance equation for closed system is Q net in minus W net out equal to delta system. Right. Kalau kita kembangkan equation, come as Q ni tak payahlah kembangkan because we need to find this Q. So this Q equal to W out plus delta T system. Okay, ini yang kita dah susunkan. Kemudian this is the property that we need to find. Okay, to Q net in. Expand this equation, it become as this. W out minus WE plus WB plus delta U okay, so this one is this, and delta E system is this one. So saya harap kamu faham yang ini. Okay, kemudian from these equations, W out minus WE plus WB, delta U, delta KE, and delta PE can cancel the not related properties. Ada property di sini yang tak berkaitan. Contohnya W out. W out tidak diberikan dalam soalan. Okay. Kita tak ada W yang keluar daripada sistem. No, we don't have any W out from the system. Out of the system. So we can cancel W out. And then W in, this W in is work done on the system. Okay. Ketika sistem tu beroperasi. So this W in is not related. But we have only WB yang kita dapat tadi. Yang negatif tadi. Okay. So this is the remaining property. And then next kita lihat pula delta U, delta KE and delta PE. Delta U, setiap sistem yang mempunyai, for each system that they have any substance, they have their own internal energy. As long as they have a substance, the system need to consider internal energy. Mesti ada internal energy dalam setiap substance. So, kekalkan delta U. How about delta KE? Delta KE tidak ada kaitan. It's not related in this question because the piston cylinder device is not moving. Piston tu, piston yang bergerak atas ke bawah, tapi piston silinder sebiji piston silinder tersebut tidak bergerak ke mana-mana. Silinder tersebut tidak bergerak ke mana-mana. That's why they don't have any kinetic energy. So we can cancel. And then same to potential energy. Same for potential energy. The piston cylinder device is on the ground, not on at the top of any mountain or hill. So that's why delta PE juga kita jadikan dia kosong. It's not related. So yang tinggal hanyalah WB, and the value is what? Minus 16 joule plus delta U is minus U1, small U2 minus small U1. Pun kita dah belajar tadi, this U adalah delta U bermaksud U2 minus U1. And we have learned juga besar sama juga dengan M, sama macam tadi, B besar sama juga dengan M. That's why we have this one. From here, we have this. Okay, so untuk U2 dan juga U1, tadi kan kita ada diagram, right? So TV diagram. Adalah P1 sama juga dengan 500 Pascal. Okay. Then state 1 di sini. State 1 adalah superheated vapor. Dan state 2 sini. Dia adalah saturated liquid vapor mixture. So di chapter 2 kita dah belajar kan, we can change this yang ini kepada apa-apa saja property. Contoh sekarang U lah, sebab kita nak cari U. We need to find this U1 and U2. So yang ini turunkan dia ke bawah. And find this. Yang ini pula dapatkan U1. So from here barulah kamu masukkan nilai yang ini ke sini dan dapatkan nilai U1 masukkan ke sini. Macam mana nak cari U1 dan U2? We have done a lot of exercises before this. So in tutorial number 2 pun kita dah belajar kan, how to determine properties for saturated liquid vapor mixture, and then how to determine the properties for superheated vapor. Yang ini kita dah belajar di tutorial 1. Tutorial 2. Okay. How we solve heat transfer. So the final answer, as I said just now, ini boleh tadi yang siapa yang tanya tu, macam mana? Saya harap kelas penerangan kali ini.
Okey, Doktor, boleh.
Okay. Okay, Next question is another question. Next question is question number 15. Question number 15. A piston cylinder device with a set of stops on the top contains 3 kg of saturated liquid water at 200 kilopascal. It is now transferred to the water, causing some of the liquid to evaporate and move the piston up. Piston up means that the piston only, the piston is moving, not the system. The piston only. The system is piston and cylinder. So cylinder is not moving. That's why KE tadi kita boleh jadikan dia kosong. Okay. Yang bergerak hanya piston sahaja. Boundary saja bergerak. But the system itself, sistem yang inilah, ni yang dikatakan sebagai sistem. Okay. Piston and cylinder device. This is the system. So the system is not moving. So KE equal to 0. PE pun 0 sebab dia on the ground, not at the top of hill, any hill or mountain. Okay. Continue to the question. When the piston reach the stops, the enclosed volume is 60 liter. More heat is added until the pressure is doubled. So the process on a PV diagram with respect to saturation lines, determine first the amount of liquid at the final state, the final temperature, and the total work and heat transfer. So this question is very tough, okay, very tough because first they have 3 states. State number 1, state number 2, and state number 3. For this, only discuss the system that have 2 states only. State number 1 and state number 2. But now they have 3 states. State 1, state 2, and state 3. That's why I say this question is very tough. And then second, need to find the amount of liquid, not the amount of the substance. Amount of liquid here means that MF. Amount of liquid, MF. So now let's try. Please focus on this discussion. For this explanation, that you know, have some ideas for the case of the system that has 3 states. Okay, the way we solve this question is actually same as what we did before. Follow the 4 steps. Number 15. First step is down all the value given to the question. Look back to our question. A piston cylinder device, set of stops on the top contains 3 kg. So mass is gram. Of saturated liquid water So that's mean phase one or initial phase is saturated. Okay, at 200 kilopascal. P1 is 200. Heat is now transferred to the water. This is second state. Okay, heat is now transferred to the water, causing some of the liquid to evaporate. What does it mean? For phase number 2, second state, they have an amount of liquid and amount of vapor. Because it's stated there, some of the liquid to evaporate. That means phase number 2, phase number 2, the phase is saturated. Or for the case of examination, you have to write in full. Okay, don't write saturated mixture. Write in full text. Saturated liquid vapor mixture. But for this discussion, I just make a short form, saturated mixture. Okay, causing some of the liquid to evaporate and move the piston up. Okay, that is state number 2. When the piston reaches the stop, the enclosed volume is 60 liter. That means 2, volume 2, okay, equal to 60 liter. Okay, that is state number 2. For state number next statement, more heat is added until the pressure is doubled. So now it is state number 3. More heat is added. Once the piston reach the stop, okay, the stop, then they give another heat until the pressure is doubled. So that means pressure 3 equal to double of pressure number 2. Okay, show the process on a PV diagram with respect to saturation lines and determine amount of liquid, final temperature. Amount of liquid here is MF at the final state. So we write 3, or we can say, or we can write as M3F. M3, state number 3, and the liquid F. Finally, determine this one, and then final temperature 3, total work W, and heat transfer. Okay, so next pada soalan dalam step 1 juga, in this step number 1, can write this one, V2 is actually equal to V3. Okay, this is another hint from the question. When the piston reach the stop, the enclosed volume is 60 liter. So that means V2 and V3 are same. Okay. More heat is added until pressure is double. So piston tadi dia akan stop di atas untuk state 2 dan untuk state 3 heat diberikan, piston masih di atas juga. So that means V3 sama dengan V2. Okay. Next, step number 2. Sampai sini ada apa-apa soalan? Sebelum kita pergi ke step nombor 2. Ada apa-apa soalan? Kalau ada, beritahu jangan simpan. Di hujung baru kamu tanya. So nanti lambat lah. Okay, next, step number 2, draw PV or PV diagram. So in this case, pressure is given. Kita ada pressure, okay, 1 to 100 kilopascal. So draw PV diagram because pressure is given, right? So pressure is given, so we draw the temperature versus specific volume diagram. And step number 3, transfer all the information given in the step number 1 into our diagram. So pressure 1 equal to 100 kilopascal. Phase 1 is saturated liquid. Phase 1 is saturated liquid. So saturated liquid is here. This is saturated liquid point. And therefore this is phase 1. Okay. Next, phase 2 phase 2, it is saturated at state number 2. So for this case, look at the question again. They have a hint, another hint that we forgot to write, which is pressure 2. For this case, pressure 2 is equal to pressure 1. Okay, why? Because if you look at statement number 1, sentence number 1 and sentence number 2, they have a hint. A piston cylinder device with a set of stops on the top contains 3 kg of saturated liquid water at 200 kilopascal. So now the pressure 200 kilopascal is P1. Okay, continue to the second sentence. Heat is now transferred to the water, causing some of the liquid to evaporate. That means the pressure is constant. At the same pressure, heat is given, causing some of the liquid evaporate. Okay, that is the hint. Clue yang kita boleh dapat daripada ayat nombor 2. Heat is now transferred, causing some of the liquid to evaporate. Okay, that is the hint. Clue yang kita boleh dapat daripada ayat nombor 2. Heat is now transferred, causing some of the liquid to evaporate. Okay, that is the hint. Clue yang kita boleh dapat daripada ayat nombor 2. Heat is now transferred, causing some of the liquid to evaporate. daripada saturated liquid phase 1, heat diberikan yang mana sebahagian daripada liquid tersebut evaporate. So that's why state number 2 is located on this same pressure line. So P1 equal to P2. So the process is like this, from 1 to number 2. Okay, next, volume V2 is 60 liter. Yang ni kita tak boleh plot kan lagi. And then P3 equal to double P2. So double P2, as we know, P2 is 200 kilopascal. P2 is 200 kilopascal. Therefore, P3 is 400 kilopascal. In our TV diagram, we only have pressure constant line for 200 kilopascal. So we need to draw another pressure constant line that is higher than 1. So here is 3, where the value is 400 kilopascal. Okay. Lagi tinggi garisan bermaksud lagi tinggi tekanan. Okay, semakin tinggi garisan tekanan, pressure line, makin tinggi nilai tekanan tersebut. So that's why 400 kilopascal is higher than 200 kilopascal line. Okay, now next is this volume. Okay, this volume. This means specific volume 2 equal to specific volume. Okay, volume 2 equal to volume 3, or specific volume 2 equal to specific volume 3. So if we look at our TV diagram, we have state number 2 here, right? State number 2 is here. If you draw the line, this is where the V. Know that V2 equal to V3. So therefore, V2 here is actually equal to 3. So we can drag this line. Number 3. Faham, eh? So the process from 1 to state number 2 and then move to state number 3. The process looks like. Okay, ada soalan tak di sini? Ada apa-apa soalan nak ditanya? Kalau faham, bagi thumb up sekali. Siapa yang faham? So ada positive respon. So kalau yang tak faham, sila tanya. Jangan tunggu di hujung baru nak tanya. Okey, apa lagi yang boleh kita masukkan? Saya rasa itu saja yang boleh kita masukkan. Cuma in step number 3, we can actually analyze our diagram. For example, state number 1 here, the V is 1. This equal to F at the given pressure. So V2 dan V3 here, since the state is saturated liquid mixture, so we can use the equation F at the given pressure tambah X F at the given pressure. Okay. Kemudian next, this one, this is as usual P set at the given pressure berapa? 200 kilopascal. For this one, this is another T set, but for 400 kilopascal. Set for 400. Okay. Boleh setakat ni. So we have two saturation temperature. First for 200 kilopascal, second for 400 kilopascal. Okay, so I think that's all that we can analyze from our TV diagram. So now next, let's try answer question number 1. Step number 4, by using the equations, solve the problem. Okay, the first one, we need to find mass for liquid at final state. An amount of liquid at the final state. Okay, for final state, yang ni lah, state nombor 3 ni. This one. Find this mass. So we know that 2 equal to 60 liter. Is equal to 0.6 the cube. Right. And this value also equal to 3. So therefore 3 is equal to 0.6 is equal to m more v. Faham setakat ni? And this one is m P3, this one. At the given pressure plus x at the given Vx x Vfg at the given okay. The pressure here, the pressure pressure, okay, and this pressure is 400. Okay. Jangan silap, bukannya 200, not this one, okay, because 200 is for state number 2. Kalau you nak cari state number 2, then this is the pressure, 200. But for final state, state number 3, the pressure is 400 kilopascal. So jangan silap antara 400 kilopascal dan 200 kilopascal. Okay, so from here you can find the quality. So quality X equal to what? 0.6 bahagi mass. Mass adalah per kilogram. This one. Okay. Mass is 3 kilogram. Then tolak at the given pressure bahagi dengan okay. So the answer should be 0.041. 0.041. The answer should be 0.041. So we solve for the question A. Ada soalan tak untuk A? For the first question, 15A, 50. Kalau tak ada soalan, we move to second. Second ini A, This is A. The amount of liquid No, not yet. We didn't finish yet. We didn't yet for A. For A, yang ini kita baru dapatkan nilai X. Okay, let's continue for A. As we know, X is equal to M, right, mg over M total. Okay, kita nak cari MF. So we need to rearrange our equation here. So this one, this is mg MF okay. This is mg Right, so mg means m mt minus m f over m. Okay, betul kan? Kemudian x sama juga dengan minus right. So therefore mf equal to minus x bracket 1 minus x. So the answer should be 2.7 kilogram. Okay, this is the answer. Okay, ada soalan untuk question A? Saya beritahu di awal tadi, soalan ni agak susah, but kita boleh selesaikan as long as we follow the steps. Step 1, step 2, step 3, and step number 4. Okay, ada soalan? So A, sebelum kita berpindah ke soalan B, the final temperature. So B, very simple. For B, final temperature T3 is equal to T saturation at the given pressure 400. Okay. Why? Because look back to our diagram. Okay. Our diagram here, this T3 is actually equal to T set. T3. Okay. So look at table temperature, pressure table, table A5 at 400 kilopascal. The saturation temperature is 143. 143.61. Very simple, right? As long as we have PV diagram or PV diagram, know how to analyze the diagram, then we can answer the question very easily. Okay. For example, this question B. Okay, next. So C, to move to a new whiteboard. so for C, have to find work W and Q. Okay, before we answer this W and Q, let's draw again our diagram. The first pressure 1 equal to 200 Pascal. It's actually equal to P set pressure 1, and then have another pressure constant line. It's higher than the previous pressure, equal to 400 Pascal. Let's point the state. First state is here, right? Saturated liquid. One. State 2 is somewhere here. Some state number 3 is located here. Pressure 400 kilopascal. Then if we track this one, this is B1. Set at a given 400 kilopascal. Okay, so here is our PV diagram. So let's find the work done. Work done or total work. So total work. For total work, as what we learned before, the area under the graph is referring to the work done or boundary work, right? So the area under the graph is this one, right? Area under the graph. So here is W. So find the area under the graph, then we get the W. Or we can do it one by one. For example, work done for process 1, process number 2, and then plus work done for boundary work for process number state number 2 to state number 3. Total work W total. We look at our TV diagram. The boundary work for process number 2 to process number 3 is value is 0. Kosong, kosong. So this one equal to 0. 0. Because this constant volume, isochoric process, the boundary work is 0. No area under the graph for process number 2 to process number 3. For state number 2 to state number 3. So that's why boundary work process state number 2 to state number 3 is 0. Okay. Now let's continue for this one, vertical, integration 1 to 2. Know that this process is isothermal process. Right. So for isothermal process, not isothermal, sorry. Isobaric pressure is constant. Right. Pressure is constant at 200 kilopascal. So this is isobaric process. Isobaric process. So P is constant. 1 to 2. So pressure minus V1, right, as M pressure, specific volume 2, more V2 minus specific volume 1. Okay, so find this value. Once you know this value, then put it here. Put it. Okay. So the answer should be total work should be 7.4. 7.2. The answer for work done. Okay, any question for total work before we move for heat transfer? Persoalan? Kalau tak ada, bagi thumb up sikit supaya saya tahu kamu faham. Orang yang sama juga. Yang lain macam mana? About the rest? Yang lain macam mana? Untuk final dan juga midterm nanti adalah soalan-soalan yang macam ni. Okay? Ada yang senang, ada yang susah. Yang senang macam soalan nombor 11 tadi. Yang susah seperti yang kita buat sekarang. Tak susah sekiranya kamu ikut step. Follow the step, then I think not too difficult for you to answer the question or to solve the problem. So make sure you follow the step. Okay, next for Q. So Q, it apply the energy balance equation. Net E minus W out equal to delta term. So we want to find Q equal to W net out plus delta E. W net out is actually W out minus WE plus WB. Then delta E system, delta U plus bracket, okay, delta PE. Okay, let's cancel the non-related properties. Based on the questions given, we can delete some of the properties here. Okay, for example, W out. So W out is work done by the system. So for this piston cylinder device, it doesn't mention any work done by the system. So we can cancel W out. As well as W in, it doesn't mention anything about W in, work done on the system. So we can cancel W in. How about WB? WB is boundary work. Boundary work means that the work produced due to the movement of the piston. Piston is moving up and down. So the boundary is changing. The boundary is changing. The boundary is moving. So we keep WB. WB. So for this case, delta U, as I said, as long as they have a substance, then we keep U, delta U. Substance. Every matter that has a mass, they have their own internal energy. So we keep a delta U. How about next? Delta KE. Delta KE, kinetic energy. If they have a velocity, then we need to consider kinetic energy. If they don't have any velocity, or the system is not moving, static, so we can cancel delta KE. So if you look at our question here, is piston cylinder device. Piston and cylinder as a one system. The piston only moving, but the cylinder is not moving. So therefore, can be neglected, or we can cancel KE, as well as delta PE, potential energy. The position, the elevation of the system is not changing. heat remain on the ground. So therefore, PE equal to 0. Now we have WB and delta U. So it's very simple, as it is same as what we did in the previous question. So let's continue. WB, oh not WB, Q net in right here. Net equal to WB, have WB plus delta U. So delta U here means M small u minus small u1. Okay. We have done in tutorial number 1, we can change this V axis with another properties, right? So for this case, we want to find internal energy, so we can change. So therefore here, we can change to U1. One is okay. For that, before I solve this question, have to careful with this delta U. Okay? Delta U here means U final minus U term. Okay, so final here, the final is number 3, this one. This is the final one. Initial, of course, number 1. Okay, so that means this is not U2, but okay. So please be careful. I have 3 states here. State 1, state 2, and state number 3. So final state is not U2. Minus 1. So this is U. Find this U. Okay, U1 is F at the given pressure, and U3 is F plus at the given pressure plus X F. Okay, so the answer should be, the final answer for Q should be 550.6. 500.2. Itu saja untuk soalan 15. So, saya harap kamu jelas dengan tangan yang diberikan untuk soalan nombor 11 dan juga soalan nombor 15. Okay, ada apa-apa soalan untuk C ni? Question C, any questions? Faham ke? Kalau faham, berikan thumb up supaya saya tahu. Okay. Okay, yang tak faham, ada soalan? Siapa yang tak faham? Okay, so itu sahaja daripada saya untuk petang ini. Saya harap kamu selesaikan menjawab semua soalan yang ada dalam tutorial 1 sehingga tutorial 3 ini. Pandukan kepada penerangan yang telah saya berikan. So, selepas minggu depan cuti midterm break. So, after midterm break, you will have midterm test. So, untuk midterm test, ketiga-tiga bab masuk. Bab 1 sehinggalah bab 3. So, please some revisions and answer all the questions in tutorial 1 until tutorial number 3. So you know how to read the table, how to get the data from the tables, and know how to draw TV or PV diagram, know how to analyze the diagrams. After that, summarize all the equations as well as the steps on how we solve the problems. Sihat saya lah. So, terima kasih semua. Dan satu lagi, hari Jumaat ini kita akan ada quiz. Okay? Saya akan buat quiz dan saya akan informkan pada kamu nanti chapter yang akan masuk. Okay? So, itu saja daripada saya. Terima kasih semua. Assalamualaikum warahmatullahi wabarakatuh.
Masih ada